Hi, in this lecture I will show you how to convert an NFA to a DFA. First of all, NFA, let me tell you that NFA and DFA has the same expressive power. When we use NFA, when we know the goal, but we do not know how to reach the goal, that case we use the all possible way to reach the goal, and after that we try to maintain all the properties of a DFA to convert it to a DFA. DFA has three properties. First, that each of the state must consume all the elements of the alphabet, which is not applicable for NFA. And after that, after consuming an alphabet by a state, it may goes to a unique state, not more than one state, which is also not applicable for NFA. DFA does not accept lambda, but NFA accept lambda. Now, if we can remove these three properties, if we can implement these three properties in NFA, that case easily we can convert an NFA to a DFA. So, in this example we will try to do the same thing. Let us first start with the first example. This is obviously an NFA. Why? Because the alphabets are A and B, right. So, at Q0 A is consumed, but B is not consumed. Not only that, Q1 consumes lambda. So, we can say that this is an NFA. Now, how to convert it to an equivalent DFA? Before converting it to an equivalent DFA, let me tell you that in case of DFA, Q0 will be the initial state as it happens in case of an NFA. Now, we have to check that what will happen if I give A to Q0 and B to Q0. Now, if I give A to Q0 directly, it is going to Q1, as well as if I give A lambda instead of A only, it is going to Q2, and we know that A lambda and A both are same, because lambda is a null string. So, if I give A to Q0, it is going to an equivalent state where the properties of Q1 and Q2 exist. So, if I gave A to Q0, it is going to a equivalent state of Q1 and Q2. Now, let us check what will happen if I give B to Q0, as B to Q0 is not mentioned in NFA. So, can we say that without giving B to Q0, the machine is reaching to the final state? So, B is not desirable for that machine. So, if I give B to Q0, so it will goes to a state from where we can never achieve the final state. So, after giving B to Q0, it will goes to a trap state or phi. So, if I give B to Q0, it is going to phi, where after giving A or B, it will not react anything. Now, let us check, after giving A and B to Q0, we are getting two new states, one is phi, another is Q1, Q2. Now, let me check with what will happen if I give A to Q1, Q2 and B to Q1, Q2. Now, if I give A to Q1, Q2 means delta Q1 A union delta Q2 A. Now, at delta Q1 A, what will happen? Delta Q1 A directly it is going to Q1, as well as after giving A lambda, it is going to Q2, and at Q2 A is not mentioned in this case. So, Q2 A is not desirable for that machine, means that after giving A to Q2, it is no in any case it is not helping us to leading to the final state. So, in this case, instead of giving phi, you have to give lambda. Why? Because if you have two states where you are applying the same input, one input is leading you to a valid state, this one another input is leading to an invalid state, this one, that case the invalid one will lead to lambda instead of phi, because we cannot put phi, that is the trapping state, with the valid state to make a new state. Is this clear? But in both the states, if they are leading to an invalid state, that case it must be phi. That what happens in case of Q0b, this case. So we can say that if I give A to Q1 Q2, it is going to Q1 Q2, right. Now let us see that what will happen if I give Q1 Q2 B. So it should be Q1 B union delta Q2 B. Now Q1 B, in case of Q1 B, it is going to Q0, right, because direct Q1 B is not there, but Q1 lambda B is there. So after giving lambda and B, it is going to Q0 union. In case of Q2 B, again it is directly going to Q0. So we can say that Q1 Q2 B, it is going to Q0. So what are the new states appears after giving Q0 A and B, phi and Q1 Q2. So in all the cases we have checked what with A and B, that is the all the input elements of the alphabet. Now is there no other states has left? So we can say that this DFA is complete except the determining the final state. So what should be my final state? As Q1 is the final state over here, so wherever Q1 appears, all will be my final state. So this one will be my final state. So this is the equivalent DFA of this respective NFA. Now let us try with another problem. Now in this problem it is again an NFA. Why? Because at Q0, after giving A, it is going to Q1 as well as Q0. It is going to more than one state. Not even that, at Q2 0, what will happen at Q2 0, it is not mentioned. So easily we can say that this is an NFA. Now what should be its equivalent DFA? Same manner, Q0 will be the initial state. Now we have to check that delta Q0 0 as well as delta Q0 1. Q0 0, it is going to Q0 Q1, and Q0 1 it is not mentioned. So oh no, sorry, Q0 1 is mentioned, that is Q1. So we can say that at Q0 0, it is going to a equivalent state of Q0 Q1, and Q0 1 it is going to Q1. Now let us check with delta Q0 Q1 0 and delta Q0 Q1 1. Delta Q0 0 will be delta Q0 0 union delta Q1 0. Now Q0, what will happen to Q0 0? Q0 0, obviously it will be Q0 Q1 as we have seen in the last transition function. And what will happen in case of Q1 0? So to check the Q1 0, again we have to refer to the NFA. In NFA, it is seen that Q1 0, it is Q2. So if I give Q0 Q1 0, if I give Q0 Q1 0, it is going to a new equivalent state of Q0 Q1 Q2. So I am giving 0, it is going to a new state where the properties of Q0 Q1 and Q2 exist. Now let us check for Q0 Q1. Now for Q0 1 for Q0 1, it is going to Q1, right. Sorry, I have to write it as Q0 1 to to remove any confusion, right. So, Q0 1 it is going to Q1 union Q1 1 it is going to Q2. So, direct values are there. So, after giving 1 to Q0 Q1 it is going to a new state where the properties of Q1 as well as Q2 is maintained. Now, let us check for 0 and 1 for Q0 Q1 Q2 and Q1 Q2. Delta Q0 Q1 Q2 0, that is delta Q0 0 union delta Q1 0 union delta Q2 0. Now, delta Q0 0 it is Q0 Q1 union delta Q1 0 it is Q2 union delta Q2 0 is not mentioned. So, it must be lambda. So, at delta Q0 Q1 Q0 Q1 Q2 0 it is going to the inner loop. Now, what will happen if I give delta Q0 Q1 Q2 1 delta Q0 1 union delta Q1 1 union delta Q2 1. So, delta Q0 1 it is Q1 union delta Q1 1 it is Q2 union delta Q2 1 is again Q2. So, if I give 1 to Q0 Q1 Q2 it is going to Q1 Q2. Now, what are the other states left? One is Q0 Q1 Q2, another is Q1 Q2 and Q1. Now, let us check for only Q1 Q2 and Q1. So, let us check for Q1 Q2 delta Q1 Q2 0. Delta Q1 0. So, what will happen for delta Q1 0? Q1 0 it is Q2 union delta Q2 0. So, Q2 0 is not mentioned. So, if I give Q 0 to Q1 Q2 it is going to a new state, that is Q2. Okay. Now, let us check for delta Q1 Q2 1, that is delta Q1 1 union delta Q2 1. Now, Q1 1 it is Q2 union Q2 1 it is Q2. So, if I give 1 to Q1 Q2 it is going to Q2 only. Now, we have only two states left, that is Q1 as well as Q2. Now, let us check for what will happen if I give 0 and 1 to Q1 and if I give 0 and 1 to Q2. I think this is already shown in case in NFA. So, we do not have to write the transition functions union again. So, at 0, if I give 0 at Q1 0 and 1 both, if I give 0 and 1 both at Q1 it is going to Q2 only. So, I can write it directly. If I give 0 and 1 it is going to Q2. Now, what will happen in case of Q2? In Q2 if I give 1 it is going directly to Q2 and if I give 0 it is not mentioned. So, easily I can write that it should goes to phi, and in phi if I give 0 and 1 it will remain in the same state. Now, this is my complete conversion of NFA to DFA except the determining the final state. Now, what should be my final state? As Q1 is the final state. So, wherever Q1 appears all the states should be my final state. So, here Q1 appears, here Q1 appears, here Q1 appears and here Q1 appears. So, this is my final state and this is the equivalent transition function. Hope you have understood that it becomes little bit complex because all the properties are not maintained in the NFA. So, we have to consider all the states. Now, let us see another example. So, this is the NFA, and the equivalent, what should be my equivalent DFA? So, obviously in equivalent DFA this Q0 should be there. Now, we have to check that what will happen if I give 0 to Q0. So, delta Q0 0, obviously directly it is going to Q1, but if I give lambda 0, because lambda is already also mentioned over there. So, if I give lambda 0, it must go to Q2 also. So, is there any other states we have to check? Yes, it is going to Q0 also. If I give lambda 0, look at this, if I give lambda and 0, it is going to Q0. If I give lambda 0, it is going to Q2, and if I give 0 directly, it is going to Q1. So, it should be Q0, Q1, Q2. So, it should be Q0, Q1, Q2. So, do not underestimate the power of a lambda. So, if lambda is there in your NFA, you have to check that what will happen if I give lambda before the alphabet and what will happen if I give lambda after the alphabet, because entire string will remain same, but the transition may differ. So, it should be Q0, Q1 and Q2 equivalent state. Now, let us check what will happen if I give Q0 1. So, if I give Q0 1, that means the Q0 1 directly is not there, but lambda 1 is there. So, if I give lambda 1, it is going to Q1 as well as it is going to Q2. How? So, if I give lambda 1, it is going to Q1, and again if I give lambda 1, it is going to Q2. Okay. So, if I give 1, it is going to Q1, Q2. Now, I have to check for what will happen if I give 0 to Q0, Q1, Q2 and 1 to Q0, Q1, Q2. To delta Q0 0 union delta Q1 0 union delta Q2 0. Now, delta Q0 0, delta Q0 0 already I have seen that it should go to Q1, Q0, Q1, Q2. So, if I find out that after giving an alphabet to a state, it is going to all the states that are available in your NFA, it is not required to check for the other cases, because it must be within the set of Q0, Q1, Q2. Still, we will check that what will happen in case of Q1 0. So, if I give Q1 0, it is going to Q0 as well as Q2 also, even Q1 also, because it is 0 lambda. So, it is going to Q0, Q1, Q2 union delta Q2 0, delta Q2 0, it is going to Q2 only. So, ultimately I am getting this one, right. Now, let us check for delta Q0, Q1, Q2 1. it must be delta Q01 union delta Q11 union delta Q21. So, Q01 directly Q01 is not mentioned, but from this example I can say that Q01 will be Q1 Q2, right. Sorry, it should be Q1 Q2, it should be Q1 Q2 union delta Q11. So, if I give Q11, it is going to Q1 as well as Q2, Q1 as well as Q2. Is there any other state it is going? I think no. Okay, fine. And for Q21 it is going to Q1. So, if I give 1, so if I give 1 to Q0 Q1 Q2, it is going to Q1 Q2. Now, let us check for Q1 Q2. Delta Q1 Q2 0. So, delta Q1 Q2 0 is Q1 0 union delta Q2 0. Now, for delta Q1 0, it is going to Q0, then it is going to, if I consider only 0 lambda, it is going to again come back to again Q1, and if I give 0, it is going to Q2. Okay. So, delta Q1 0, it is going to all the states, that is Q0, Q1 and Q2 union delta Q2 0, and in Q2 0 it is going to Q2 and then nowhere else. So, it is going to Q2 only. So, ultimately if I give Q1 Q2 0, it is going to Q0 Q1 Q2. So, if I give 0, it is going to Q0 Q1 Q2. So, no other states left. So, this is my complete conversion of DFA. Now, what should be my final state? The final state, as Q1 is the final state. So, we have to check that wherever Q1 appears, all will be my final state. So, this one is my final state and this one is my final state. So, this is the equivalent DFA. So, try with other examples also. As much as examples you will solve, you will be more confident.